Hey, good morning, or good afternoon, or good evening, whatever it is. Welcome to, well, you were expecting equations of tangent lines, but really we're going to start out with basic derivatives, day two. So this is a problem that typically what happens is someone's absent on the day when when we discover the rules for finding derivatives, and they'll come back and we'll say, okay, everybody, let's do this problem. And folks who weren't here are going to start doing it with the limit as delta x, that sort of thing. And the rest of us would just go through and we'd go, oh, we can do the derivative of this. It's 20x cubed minus 9x squared plus 4x minus 153, and then we're done, and the person's still just writing down the limit as delta x, and then hilarity ensues, and we let that person in on the big joke. And so there you are, basic derivatives, day two, done. Now, on to the real topic. The real topic is equations of tangent lines. This picture is actually taken from my front porch. I was sitting out in the morning drinking coffee this summer, which was pretty much my morning habit. Get up early, have a cup of coffee, sit on the front porch, and I looked out and I went, oh my God, there's a tangent line. It's the telephone wire and the mountain, and I went, that's so cool. I don't know why I never noticed that. We've lived here for however many years. I never noticed that tangent line. Tangent line touches the curve at one point. So there's the mountain in the background, there's my function, and then we've got the equation of the tangent line right there. Now for one sec. Hey, sorry about that. So where was I? I was talking about my front porch. That was Mrs. Riggs, just stopped in to chat for a minute. And you're probably wondering now, why are you sitting on your front porch thinking about calculus? I have no answer for that. But equations of tangent lines. Let me. There it is. Sorry, I'm going away, but now I'm back. Okay, so now I can actually maneuver. Here we go. Equations of tangent lines. So what we want to do is we want to find the equation of a tangent line. Simple enough. The topic's called. We ought to be able to figure out how to do that. So to find the equation of a line, what we need to know is we need to know a point on the line, and we need to know the slope of the line. And then we can put our equation in point slope form, right? Point slope form. So first problem, find the equation of a line tangent to this equation when x equals 2. So in order to find the slope, what's the slope of a tangent line? That's right, you got it. The slope of a tangent line is the derivative. That's why we use them, derivative. I think I can spell that. All right, so it's the derivative. The slope of the tangent line is the derivative. So we need to start with the derivative. What's the derivative of y equals 3x squared plus 2x minus 5? I think it's 6x plus 2. Do you agree? Okay. So that's going to be the piece. We're going to need to know the actual number, so we're going to evaluate that when x equals 2. When I write a line like that, that means evaluate when. And so we evaluate when x equals 2. 6 times 2 is 12, plus 2, there it does it again, plus 2 is 14, and it always takes my pen away, equals 14. 12 plus 2 is 14. So that's the slope of the tangent line. Slope of the tangent line, right there. Okay, so if we're looking for y minus y naught equals m x minus x naught, okay, we've got m, 14. We've got an x value. There, that one. We just need a y value, an initial y value. Where's the initial y value come from? Well, it comes from figuring out when x is 2, what's the value of the function. So we'll do a little sidebar over here. So y equals 3 times 2 squared plus 2 times 2 minus 5. Remember order of operations, 2 squared is 4, 4 times 3 is 12, 2 times 2 is 4, so 12 plus 4 minus 5, 16 minus 5, I think is 9. Does that sound good? 9. So we've got enough to fill this in. We know this is my y, that's my x, this is my slope, and away we go. Y minus 9 equals 14, x minus 2. Ta-da! We have written an equation, and that's all we need to do is an equation of a tangent line. Ta-da! We're great. Super. Slope of the tangent line. Derivative. There it is. There's the tangent line right there. You can't see it, but it's right there. That's the tangent line. Crosses right at exactly that point when, what do we say? when y is 9 and x is 2. I think that's, let's see. That's right there. I don't know. Something like that. Okay. So, next thing is to find the location of a horizontal tangent line. So, first question is, what's the slope of a horizontal line? 0. What's the slope of the tangent line? The derivative. Right? And so, if we're looking for a horizontal tangent line, we need these two things to be the same. So we need to know where is the derivative equal to 0. So if we're trying to find the location of a horizontal tangent line for this particular little thing right here, find the location of a horizontal tangent line for that. I'm going to go to the next page, so I have plenty of room. So we want to know is when is the derivative equal to 0? So what's the derivative? Y primed, we write that down, equals 3x squared minus 12 minus, I want to just undo, that's what I'm trying to do. Now I'll get the pen back. Minus 12, which is how we write 12, plus 9. Okay, we want to know when that is equal to 0. How do we solve an equation like that is equal to 0? It's a quadratic equation. Quadratic formula works. We might be able to factor it. I'm happily looking and going, oh, everything's divisible by 3. How delightful. And so I rewrite it that way. And then I go, ooh, I probably can factor this. Since I don't have many choices for 3, I bet you those are the ones to use. And they are going to both be negative. That gives me the plus 3 and the negative 4. So that means I would have horizontal tangent lines for that when x is equal to 3 and when x is equal to 1. Yay! Okay, so that's where we'd have a horizontal tangent line. So the way we find a horizontal tangent line is we find out where the derivative is equal to 0. What's a horizontal tangent line? What's that graph look like? What? There you go. So if I drew tangent lines anywhere, if I drew one right here-ish, it would be horizontal. Its slope would be perfectly 0. Sure, you can see that. Same thing here. Horizontal tangent line, slope equals 0. Okay, m equals 0. So we could have that be our issue, right? Good? Great. Trig functions, they have derivatives. I'm going to tell you what they are. You're going to need to get these into your brain and memorize them, but the trig functions derivatives. The derivative of sine is cosine. Let's take a look. Okay, think about the cosine, or the sine right here. If I do a slope line, it's about 1. As I work my way to pi over 2, my slope becomes 0. So if I start at 1, and I work my way towards 0, hey, it's starting to look like the cosine curve, isn't it? Okay, and then I work my way down to here, and about there, my slope is negative 1, which is about what the cosine does right there, negative 1. And then from back here, I'm about at 0 again, right? So I get that horizontal tangent line going, and then I work my way back. So it's the cosine curve. Derivative of sine is cosine. Know it, love it, memorize it, internalize it. We'll talk about what that means. The derivative of the cosine, similar reason, starts out at 0, but it works its way to negative, so it's the opposite of the sine. The derivative of cosine is negative sine. Okay, know it. These are the things that we're going to know, just like our alphabet. We need to get those in our brain, plus a bunch of other things. So if I ask you what the derivative of 3 times the sine of x is, okay, dy dx, that's what we'll do for notation on that one, of 3 times the sine of x. So the 3 is just a constant multiplier. Derivative of sine is cosine. Boom, done. Okay, let's go with y primed. Y primed, 2 is coming along for the ride. Derivative of cosine is negative sine, so I'm going to make it negative 2 sine x. And then the derivative of sine is cosine, so minus cosine of x. Done. Oops, I did these backwards. It's and y primed. Read my own stuff. And then the derivative of f primed of x. So, or the derivative of f, find f primed, that's what I'm saying. So f primed of x, derivative of x squared is 2x. Notice we didn't have to do any rewrites or anything on these, so it's nice and lovely. The derivative of cosine of x is negative sine x, so I should probably have made that into a something else. It's 2 strokes, okay. So derivative of cosine is negative sine, so let's just make it negative 3 sine x, and then the derivative of sine is cosine, and so it's going to be minus cosine of x. That's the derivative. That's how the slope is changing. If I want to know the slope at any particular point, I'd plug in an x value. If I want to know the equation of a tangent line, we could do that as we were doing, you know, a line tangent to whatever this curve looks like. derivatives, sine and cosine. Okay, again, you're going to want to know them. I'm going to want you to know them, and there we go. I think that's the end. Yeah, don't pay attention to that. We'll talk about quizzes. We've got some upcoming. I think that's about all. So, we'll see you tomorrow. We hope that you have had a lovely time watching this. Hope you learned something. Hope it's making sense. The pieces are falling together. Remember, slope of the tangent line, derivative, instantaneous rate of change, our little triangle of things that are alike, right? So let's go this way. Slope, instantaneous rate of change, and derivative, all the same, making that little triangle. All right, that was lovely. So, thanks. We'll see you soon. No, really, I'll stop this time.